India's building stock is expected to double in the next 15 years, and residential buildings are expected to emerge as the largest electricity-consuming sector in the country. To ensure this growth is sustainable and beneficial for all, it is crucial that new residential structures being built in the country are designed to be energy efficient and thermally comfortable. The Indo-Swiss Building Energy Efficiency Project BEEP aims to influence reduction in energy consumption in India by mainstreaming concepts of energy efficient and thermally comfortable building design. Thermal comfort can be maintained by regulating the amount of heat entering and exiting a building. One of these techniques is an external movable shading system, or EMSyS. This is an efficient and cost-effective way of maintaining a building's thermal comfort. EMSyS are shading devices that are mounted outside windows and can be adjusted based on the sun's position. In order to better understand the exact impact that EMSyS can have on the heat gains inside a building, BEEP conducted a performance monitoring experiment. The main objective of the monitoring was to quantify the impact of EMSyS in reducing indoor temperatures in naturally ventilated mode and in reducing the space cooling load in air-conditioned mode in a typical residential apartment. The key requirement was to identify two identical flats located in the same building, which have the same orientation and good solar exposure. The monitoring was carried out in a newly constructed residential building located in the National Capital Region. The rooms selected for monitoring in each flat had one west-facing wall which had 60% glazed area. For the purposes of the experiment, one flat was equipped with EMSyS, while the other was equipped with internal curtains. Both flats were monitored simultaneously with a similar set of instruments. Given that the flats were in a high-rise building and that the room had a balcony, vertical screen was most feasible EMSyS option to install. The methodology was developed keeping real-life scenarios in mind. In Mode 1, natural ventilated indoor air and radiant temperatures along with air velocity were measured to calculate indoor operative temperature. In Mode 2, air-conditioned mode, the main intent was to calculate space cooling demand. The ceiling fans in both flats test rooms were operated at full speed to imitate real-life cooling scenario in summers. A precise set of equipment needs to be used to ensure accurate data is logged throughout the duration of the experiment. Humidity temperature probe to measure relative humidity temperature. Turbulence probe to measure omnidirection velocity. K-type thermocouple to measure wall surface temperature. Globe probe to measure globe temperature. Temperature humidity sensor to measure outdoor temperature and relative humidity. Pyranometer is an outdoor equipment used to measure total radiation. Data was logged from all these equipment every 15 minutes. Data was logged from the balometer to measure temperature and humidity every 1 second. The balometer was used only in the AC mode. Comparisons between the room with EMSyS and room with the internal curtain showed interesting results. The natural ventilation mode has up to 3.5 degrees Celsius lower peak operative temperature as compared to the room with the internal curtains. In AC mode, the room with EMSyS had approximately 30% less cooling demand as compared to room with internal curtains. The results from the monitoring exercise have reiterated that installing a simple and cost-effective EMSyS can be a highly efficient way to maintain thermal comfort inside a building. The difference between measured air temperature and simulated air temperature is less than 5%, which shows that the simulation model can closely predict the real-life results. The data from this experiment can be used for parametric analysis in different climatic and geographical scenarios and even for different building types. Looking at the positive results from this monitoring experiment, a future study is being planned to understand if EMSyS is used in all upcoming residential complexes, then what the energy savings for India as a whole can be. EMSyS can play a significant role in making Indian residential buildings more energy efficient and thermally comfortable, while saving residents a good deal in electricity bills.